Hi, today I'm going to present a demonstration of data enrichment, how to add value to sales data through publicly available data sets. My name is Martin Madsen. I have a PhD in experimental physics and 16 years experience working with sensors, data collection, data analysis, and all kinds of different predictive model building. The demonstration today is going to use public data available through the data.iowa.gov website. What I'm looking at are liquor sales in Iowa from 2012 to about the middle of 2016. This is purchase information from grocery stores, liquor stores, convenience stores of individual liquor items, and this is by bottle. And so I have not only the amount of that they bought in terms of volume, but I also have the price that they paid for each individual unit. So together I can look at the total sales, and this is I've aggregated the sales by month over the course of the last 4.5 years or so. The blue bars are the sales in volume, and the black line is the sales in dollars. And it turns out to an average of about $14 or so per liter of liquor sold in the state of Iowa. There's all kinds of interesting things going on here. There's obviously a regular set of spikes that's happening, and we're going to drill down into this data and see what we can find out about this by enriching the data using a number of different public data sets. The data enrichment pipeline works like this. I first use a Python script to pull the data off of the publicly available REST API endpoints, and then I used Alteryx as a data combining and cleaning tool to join the data sets together and merge them and clean them up, and then finally present the output as a Power BI dashboard to look at the visualizations of the different data sets. The first piece of data is to pull the population data from the U.S. Census Bureau, and what I'm looking at is the city populations for each of the cities in the state of Iowa and their liquor sales aggregated by cities. And what I've got is then shown here is the liters per capita by month and city for cities that have more than 30,000 people in them. And this is stacked up, seeing that Ames has an average of about 1 or 2, maybe 1 liter per month per person liquor consumption, or at least purchases for liquor consumption. And then stacked on top of each other, again, the number of these data features show up as regular spikes in the data. And I'm interested, again, in drilling down more on that, and it looks like it's something that's happening in most of these cities. Looking a little more specifically at these cities themselves, in the upper right-hand window is the city population for cities with more than 30,000 people, looking at the liter consumption by year, and it looks like most of these cities are an average of about 1 liter or so per month over the course of the year. However, if I look at cities with more than 1,000 people in them, so I'm looking at smaller cities, I see that there's a dramatically larger amount of liquor consumption happening in cities like Windsor Heights and Mount Vernon and Spirit Lake and Milford, which then led me to wonder, where are these cities, and why is the liquor consumption more than 7 times higher than for cities that have larger numbers of people? We'll come back to the annual variations in the data, but first let's look at what are these cities and what are we looking at. So using geographic information pulled off of the Google Maps API, I can plot the cities and the consumption by city as a location marker. And so this is liters per capita by location. Over the whole state of Iowa, there doesn't seem to be much variation, but when I drill down into some of these other cities, I see that Windsor Heights is a location right next to Drake University. Mount Vernon is where Cornell College is located. And so looks like there's a connection between colleges and liquor consumption. And then a couple of these other cities like Spirit Lake, Arnold's Park, Milford, and Clear Lake are right next to reservoirs in the state of Iowa. So there might be some connection to vacation or other tourist attractions and liquor consumption. And then the last one is Toledo, Iowa, which is right next to the Misaki Casino. And so it makes sense that there's a connection between the casinos and liquor consumption as well. Looking more specifically at the colleges, I was interested in how the colleges' liquor consumption varies. And so what I'm plotting is, on the horizontal axis, the students per capita, how many students are there in the city. and then what is the average liquor consumption for those cities. And cities with no colleges in them are on the left-hand side, and they have an average liter per consumption per capita of about 0.16 or so. So it's not very large. And when I compare that to cities like our University of Iowa and the majority of the other cities that have universities in them, the liquor consumption isn't very high. But there are a couple of outliers here. It looks like Wartburg College, Luther College, and especially Cornell College, the liquor consumption per capita is off the charts compared to cities with no colleges. And I pulled this data off of the Wikipedia website to get a list of the colleges, the number of students in the colleges, and the location of the colleges in order to aggregate all that data together to show the correlation between the number of students in the college, the number of students, college students in the city, and the liquor consumption. Returning back to the consumption change during the course of the year, I look at cities with and without schools, and the bottom plot shows the liters per capita by month for cities that don't have colleges or universities in them, and there's not much of an annual change for those cities. However, the cities that do have schools in them, there's a significant change both in February and in October in the amount of liquor consumption, and my suspicion is that it's connected to athletic events. And I wanted to find out to see if there was a correlation between this. So what I did was pulled the Facebook web pages for the athletic social media posts for each one of those universities, and pulled off of Facebook all the posts that had the keywords game or football or basketball to see if there was a correlation between the sales per capita in terms of number of liters per week and the number of posts that have these keywords in them. And the big graph is shown in a linear plot and the smaller graph is in a log plot. And in both of them, it's visible that there is a correlation. The more posts that there are with these keywords in them, the larger the liquor consumption in these cities. So that supports the idea that liquor consumption is tied to the college athletic events. Instead of just looking at specific athletic events, how is liquor consumption changing as associated or connected to U.S. federal holidays? So what I did was pull data from the U.S. federal holidays and then calculated the number of days from the federal holiday to a current day, and then looked at the average sales in liquor by liter on that day. And what I find is that there is a correlation, a fairly strong correlation in the proximity to a holiday to the liquor consumption. And the correlation looks like the 7 days prior to a holiday, the stores are purchasing liquor in order to stock up for the holiday, and their purchases decrease down to the day before the holiday. And then the day after the holiday, the sales bump back up again and then continue fairly high until about a week after the holiday as they replenish their stocks after the holiday. And it doesn't matter what holiday this is aggregating all of the U.S. federal holidays. So this is a general trend, whether it be Memorial Day, Labor Day, 4th of July, Christmas, New Year's. This is an overall pattern aggregating all the possible holidays, which says something about the liquor consumption and how it correlates to these larger national events. I also wanted to know if liquor consumption was connected to what was happening in the town around the sales of the liquor. One way to look at this would be was to look at the global database of events, language, and tone. This database pulls data from news sources from around the world and then scores the data as being a positive or negative tone. Positive tone events being celebrations or positive occurrences, negative tones being disasters or crimes. And so I aggregated the data by week and found the average event tone per each week. So if there's some major event happening that was a positive thing, there would be a net positive tone per week. And then connected that to the cities based on the nearest city that sells liquor based on the events in the state of Iowa. And then looked at the total sales of liters of liquor per capita per week as a function of the average event tone, and found that there's very little correlation in there. Most of the event tones end up being neutral, neither positive nor negative, and that's where most of the sales is happening as well. Perhaps there is a slight correlation that negative events tend to lead to larger liquor purchases than positive events. I'm not exactly sure why that would be, but it might be people drowning their woes. I also was interested to see if the sales were correlated to the weather, and so I pulled off weather data from the National Oceanic and Atmospheric Administration's public data set, and correlated this by month. So what I'm looking at is the average temperature by month connected to the average sales of alcohol in liters per capita by month, and looked at this averaged over the course of the year. And for the most part, there doesn't look to be much correlation between the temperature and the sales of liter per capita, except in this upper right-hand corner where there seems to be a fairly high correlation that the higher the temperature, the more liquor sales is happening. And when I drill down to that data, where that data is coming from essentially is from Dickinson County, which is Spirit Lake, Milford, and Arnold's Park, and these are the reservoirs. And so when the weather is nice, the stores around the reservoirs are certainly doing a lot more liquor purchasing than in other times of year. Since the NOAA information, the data set also has information about precipitation and snowfall. I looked to see if there was any correlation between precipitation and snowfall. And because this is averaged over the course of the month, it doesn't look like there's much correlation here between the precipitation and the purchase of the liquor purchases. And then I think that has two pieces to it. First of all, because this is a monthly aggregation, it's large enough to not take into account individual storms. And the second piece is because this is monthly, it means that even if there were a small dip or rise based on the weather, the precipitation of the weather, those would get averaged out over the course of the month. Drilling down into the brand data, also available on the Iowa dataset, I'm looking at the total sales by brand, and what I had to do was go back through the dataset and pick out individual types of liquor and join them together in terms of a brand. There's a handful of different Captain Morgan alcohol liquor types, and I joined them all together into a single category. And so certainly the top selling liquor is the Black Velvet, and followed by Hawkeye Vodka, which is interesting because Hawkeye Vodka is not a big name except in the state of Iowa, especially near the University of Iowa, which their mascot are the Hawkeyes. So looking at the top 20 brands, I looked at trends. How did each of these brands' sales changed over the course of the last 4 years? So this is sales in terms of the number of liters, and projections for the 2016 are based on data through May 2016. So some of the brands like Black Velvet are actually increasing in their sales. The Fireball is increasing in sales. However, the Hawkeye Vodka looks like it's losing popularity over the course of the last 4 years. It's decreased maybe 10 or 15% in its sales. Instead of looking at sales by liter, I also look at sales by dollar. In that case, the ordering changes a little bit. Captain Morgan certainly is doing more sales in terms of the amount of sales by dollar, which actually begs the question, how do these different brands vary in terms of price per liter? And in looking at that, the Crown Royal is actually the most costly liquor in price per liter, followed by Jack Daniels and so on. So Crown Royal, which is doing a fairly brisk sales in terms of prices, is actually not pushing very much, is not selling very much in terms of liters, but they're getting more out of their sales because of their average price per liter is doing better. One final piece of information, because I was interested in social media and how it affects the sales. What I looked at was the sales for each of the handful of different brands for which I had Twitter accounts. And I looked at the number of postings on each one of these Twitter accounts. So for example, the Bacardi has a Twitter account and they post regularly. And what I've got in bold is the thicker lines are the sales in liter per week, and then the thinner lines are the tweets per week. And I'm looking to see if there's any correlation. If a particular brand increases the number of tweets that they're putting out, does that lead to then an increase in sales per liter in the state of Iowa? And unfortunately, it doesn't look like there's much correlation in any one of these. So it looks like the social media campaign on Twitter for each of these brands is not doing an effective job at promoting sales. So in this demonstration, I showed, starting with a publicly available data set, the sales and liters of liquor in the state of Iowa over the course of the last 4 years, and enrich that data with a handful of different publicly available data sets in order to gain insights into the types of sales that were happening, where the sales were happening, when the sales were happening, and ways in which brands could improve their impact and their sales in the state of Iowa. Thank you very much for listening, and if you have questions, comments, or further conversation, please link with me on my LinkedIn account.